In the middle of Dubai Marina, on a tiny, oddly shaped piece of land squeezed between a twisting tower and a busy highway, Dubai has built something incredible. A 365-meter tall hotel, soon to be the tallest in the world, is rising with 82 floors, over 1,000 rooms, and 150 ultra-luxury suites. Set to open under IHG's Vignette collection, it's more than just another tall building. What makes it special is how it turned leftover foundations and strong desert winds into smart design features, showing that tough challenges can lead to brilliant solutions. The site itself measured barely enough for a modest building. Nestled between the spiral form of the neighboring Ciel Tower and a major highway, the land bore the scars of a previous, cancelled development, dozens of concrete pile foundations jutting from the earth. Instead of removing these abandoned piles, engineers incorporated them into a new foundation scheme. 21 additional piles were drilled and cased, and then a continuous 48-hour concrete pour created a 12,000 square meter raft slab. That monolithic base, containing over 12,000 cubic meters of concrete and more than 3,000 tons of reinforcement steel, now underpins the entire 82-story structure. Concrete was chosen over steel for its superior compressive strength and cost efficiency in Dubai's market, where imported steel prices can fluctuate dramatically. From the raft foundation, a single central concrete core rises as the building's primary vertical spine. Surrounding that core, radial buttresses, cast using a self-climbing jump form system, climb the full height of the tower. These buttresses resemble spokes radiating from a wheel, each one supporting the core against horizontal forces. At designated mechanical service floors, large outrigger beams tie the buttresses back into the core, forming rigid triangles that transfer wind loads deep into the foundation. Additional belt walls, a continuous band of reinforced concrete around the perimeter of select floors, further stiffen the tower against sway. At heights exceeding 300 meters, wind pressure becomes the principal structural challenge. A simple rectangular prism at that elevation would act as a colossal sail, requiring immense reinforcement to prevent dangerous oscillations. To address this, architects and engineers built dozens of scale models, testing them in high-speed wind tunnels. Computational fluid dynamics simulations complemented physical testing, mapping zones of high pressure and vortex shedding. The chosen form, a tapered, slightly twisted oval, is the product of this rigorous testing. Its gentle twist guides prevailing winds to flow smoothly around the facade, minimizing turbulent eddies and reducing the structural demands on the core and buttresses. Near the summit, the tower incorporates a dramatic cut-through section, known as the Eye of the Needle. This deliberate void serves multiple engineering purposes. It allows wind to pass through the structure rather than buffet its uppermost levels. And it creates a unique architectural element that houses an elevated viewing platform. That sky-piercing deck will perch near 370 meters above ground, offering unobstructed panoramas of the Palm Jumeirah, the Arabian Gulf, and the wider Marina district. The building's exterior skin complements its structural form. Flat glass panels, delivered to site in modular units, undergo a cold bending process, gently curving them to follow the tower's twist without requiring costly hot bending furnaces. This cold bending technique allows for tight production tolerances and repeatable panel fabrication. The resulting facade is a smooth, reflective envelope that sheds wind and glare, enhances thermal performance, and reduces the energy needed for interior climate control. Inside the tower, green spaces occupy the heart of the structure in the form of 12 stacked atrium gardens. Each garden spans 6 to 8 stories and features landscape terraces, reflecting pools, and seating areas shaded by palm trees. Automated louvre on the atrium walls adjust in real time to optimize natural ventilation. Warm air rises through these vertical shafts, drawing cooler outside air through the openings in a passive cooling cycle. Computational fluid dynamics modeling guided the placement and sizing of every louvre, ensuring consistent airflow and thermal comfort without mechanical air conditioning. These gardens not only provide a lush, biophilic environment for guests, but also improve the building's overall sustainability profile. Construction reached a milestone in spring 2025, with the superstructure 99% complete. Mechanical, electrical, and plumbing (MEP) installations were nearing 80%. High-speed elevator shafts were under fit-out, and facade brackets climbed to the 72nd floor. A fleet of jump-form towers orchestrated the continuous casting of concrete for the core and buttresses, while tower cranes hoisted prefabricated formwork and reinforcement cages. Meanwhile, specialist facade teams installed cold-bent glazing panels in precise sequence, ensuring a consistent facade geometry even as the tower's twist subtly evolves with height. Once operational, the tower will deliver a range of superlative amenities. A rooftop infinity pool on the 76th floor will appear to merge with the horizon, while an observation deck on the 81st floor will offer 360-degree vistas of Dubai's skyline and waterscape. Guests will traverse those heights via high-speed elevators, capable of whisking them from lobby to pool level in seconds. Luxury suites will feature floor-to-ceiling glazing and private balconies, drawing daylight and framing the city below. Beyond its record-breaking height, the project exemplifies a broader trend in super-tall building design, integrating structural efficiency, wind engineering, and sustainability from the earliest concept stages. The concrete core and buttress system, combined with outrigger beams and belt walls, optimize material use by placing strength where it is most effective. The twisted form reduces wind loads, decreasing the need for over-design. Passive cooling gardens cut mechanical energy consumption, while the reflective glass facade improves thermal comfort. Together, these strategies yield a building that is both an engineering marvel and a demonstration of resourceful design. The tower highlights how modern construction relies on advanced simulation tools alongside traditional methods. While wind tunnel testing remains vital, computational fluid dynamics (CFD) now plays a key role, helping optimize design choices like the atrium louvre system and the tower's distinctive twist angle. The project brought together architects, engineers, and designers from the start, setting performance targets for wind comfort, energy efficiency, and structural behavior. This early collaboration ensured every design element, from the eye of the needle to atrium gardens, balanced bold architecture with technical precision. Part of IHG's Vignette collection, this upcoming hotel blends Dubai's heritage with modern design, featuring natural materials, regional art, and a narrative that ties tradition to the city's futuristic skyline. Set to become a new landmark in Dubai Marina, it not only elevates the district's luxury appeal, but also showcases how challenging sites and harsh climates can inspire cutting-edge engineering.